I'm sure you heard of big data, but before diving into big data, let us first understand what data really is and where does it come from. Data is considered a set of values, both qualitative and quantitative, that represent a specific piece of information. Every day, about 2.5 quintillion bytes of data is being created. This data can be generated from a variety of sources, such as sensors used to gather climate information, posts to social media sites, digital pictures, music and videos, online transaction records, GPS, the Internet of Things, and this is just to name a few. All of this data scattered around is what we call big data. Big data is a broad term that describes massive volumes of both structured and unstructured data, which is considered too large and complex to be processed using traditional databases and software techniques. Despite being very complex, big data has the potential to aid companies in improving operations and making more intelligent decisions. So, the question now is, what do we do with all this data? Every day we hear a news story about big data, how much there is, how fast it moves, and how it can be used for good or bad. Data affects our businesses, educational and legal system, and our society in general. So what we need to do is extract insight from data to predict and analyze certain situations to gain valuable information out of it. To process big data, you do not need huge computers. People work with the cloud and endless network of normal servers and powerful algorithms. This way, they can analyze a million pieces of data in just minutes. In Informatica, Big Data Edition, structured and unstructured data such as transaction files and flat files, social and interaction data, and machine and sensor data. A developer will create the same integration rules or mappings for our legacy system products, which now can be done on Hadoop for faster and least expensive processing. The results of that processing can be exported to a warehouse for reporting transaction or even real-time alerts. Companies are racing to find the best ways to utilize information trail that we leave behind everywhere we go in the digital world. Website visits, check-ins, social conversations, and much more. Say for example, UPS, a company that spends over $1 billion on big data annually, did not stop there. UPS uses and analyzes a wide variety of data in order to gain an understanding on different aspects by combining data from vehicles' engines to get an insight on the performance and conditions of their transportation, reducing their environmental impact, and uses address points and routes traveled in order to optimize the routing. For example, how UPS mines data on truck pickup and delivery schedules and real-time traffic patterns. The data they are using combines real-time GPS feeds from trucks, public traffic patterns data, RFID data from cargo that has been picked up or dropped off, and other sources. Now imagine when they get a call for a new pickup. Which truck should they send? The closest one, right? What if the route for the closest truck has heavy traffic jam? Or what if the cargo loaded on that truck doesn't allow space for the new pickup? Or maybe the route for that truck involves a series of steep grade changes. In those cases, the closest choice may not be the best choice. It might be more costly, less efficient, or unable to even service the customer's needs. But the only way to arrive at the optimal decision is to analyze multiple big data sources in real time. And that's just one quick example of how big data can make a big impact on a company's bottom line. Because of all this data collected and analyzed, UPS is capable of creating unique services for its customers, which in return has a good effect on the company. UPS was able to save 1.5 million gallons of fuel per year, which equals to $50 million in savings annually. Before data mining develops into a reliable application, a few challenges must be addressed. Developing the code that transforms unstructured and semi-structured data to data in a usable format is a complex process. Once a hand-coded proof-of-concept solution is created, the move to production typically raises unexpected issues as the production phase does not even include more than half of those hand-coded solutions. Plus, finding the right people with the right skills is a very difficult job, and when you do find the resources, they're both expensive and hard to retain. For those solutions that do make it into production, the underlying technology changes so rapidly that today's solution may not be the best approach to solve tomorrow's problem, and you end up in a loop where you have to repeat the process all over again. In conclusion, big data has become increasingly popular and has proven its presence as being one of the most crucial concepts affecting business information systems by providing a wide variety of valuable information.